Good. So, hello everybody. My name is Hidayat, and it is the new session of Holochain-in-Action, number 13. I hope you are doing well. So, I hope you had enough time to review previous videos in Holochain-in-Action. You know where to go and find just YouTube Holochain-in-Action. So, in description, you can find a bunch of useful links from a forum and other tools that we have in the community. And this session, Holochain-in-Action, mostly it's longer than the recorded one. If you would like to join this weekly virtual meeting, which is a community-based meeting, so that we are sharing the knowledge, we take a look at the project based on Holochain, please go to the description. There is a link. You need to fill out the application. Also, if you are from other ecosystem distributed project, warm welcome to come and share your knowledge. So today we have a really special session that we have Connor, one of the good and great community member of Holochain, that with a project Acorn. We are going to technical deep dive on the project. We are going to review the project, and there are a bunch of nice patterns that I highly recommend to watch the video, because there are a beautiful pattern from the Electron UI, cloning DNA, how the things are working. It's the way that Connor architect or design his project. I really enjoy. So, and we are going to take a look. But for the first step, I would like, and also thank you, my fantastic friend from community that joined. So we are going to start with Connor, actually, for beginning, saying hello, a little bit about team, how people can connect, how people can collaborate, and then a little bit demo of the project. And then we are going to officially start reviewing the architect, design, take a look at the code, and go deep dive as much as we can. Let's see if it's going to be finished just today. It's going to be session just one part. I'm skeptical. I think we need to do it in two parts, but let's see. If it's going to be longer than today, it's going to be officially part one. Connor, thank you. So warm welcome, and please.
Hi, Hidayat. Hi, everyone. Thanks for the warm welcome. It's exciting to be able to share again about the Acorn project, especially from a technical point of view. We've done little demos in the past, but to know that there's like an audience that's kind of interested. And the reason why it's exciting to share is because Acorn is kind of maybe an unusual project, because the code is almost half as important as what the application itself is. And the reason for that is because of the particular way that the project was started, like by and the way that the project is funded, which is by Harris-Braun Enterprises, soon to be, which is having a branch of its business which is focused on kind of innovative holochain development, and kind of like groundbreaking holochain development. What can we do to explore and to set up good patterns and try out new things, as you said, Hidayat. Yeah, so that was the purpose that with which Harris-Braun Enterprises is funding the development of Acorn. And then just to explain the sort of organizational relationship, I used to work for Holo, but I left and I started my own business with my partner Pega. It's called Sprillo, and we did that because we wanted to build like holochain applications and software, distributed software applications. And we've been doing that. We just completed like our second year of business for Sprillo. and we feel it's a really exciting time in the sort of Holochain ecosystem because projects are starting to get very real, very tangible, and certain patterns are becoming more mature, and Holochain is becoming more mature. And so it's a time of a lot of excitement in the Holochain ecosystem, which I've been playing in for a very long time, basically since the beginning of its inception, with the oldest Go version of Holochain, which was like, who knows, 2017 or something. The prototype of Holochain written in Go. I was working with Holochain since that point. So I guess it's like 4 years. Yeah, so that's a quick tour of the kind of background of why to us sharing the code is important too, because that's actually half the point of us having been building Acorn, was to share and to explore the code itself, as well as to build a good and powerful software application. So
thank you, that was amazing, thank you. And before going to short demo, and by the way, for the viewer, Connor also had a good, big enough introduction with the Holochain ecosystem with David Atkinson. For more philosophy, for more demo, you can also visit that video. But here, a little bit description, introduction, and then we are going to jump into technical detail. And Connor, how people can connect you and how they can collaborate. Oh, by the way, I think I forgot something. Acorn is a project of a collaboration and team working, peer-to-peer distributed team working, actually. I should have explained this one at the beginning and forgot. So because we are totally in the group we know, and somehow we forgot that the others maybe don't know. So if you see you would like to have such sort of idea, collaboration, team working, Connor is doing actually the great job. So Connor, how people can connect, how people can contribute, and please give us a little bit more detail here.
Sure. With me personally, people can connect with me like at connor@sprillo.com. If you're a developer, there's always like GitHub and kind of reaching out and syncing up on GitHub, filing issues. I'm very responsive to GitHub issues. For example, if it was on a technical layer that you were kind of like exploring and you found something or just wanted to ask a question, you could post an issue on the github.com/hbe/h-be/acorn. Then you could post an issue, or on the forum, the Holochain forum. I'm also very active, and so if you were to tag me in any way there to post or have questions about it, then I would definitely see anything on the Holochain forum to do with that. So those are ways you can connect, and yeah, certainly contributions on the GitHub levels are welcome. Also, we're actually, I should say, we're actually doing alpha testing with Acorn, and there is still an open form, which we can post up the link to kind of like get yourself on a mailing list that you'll receive emails to do with all the alpha testing. For example, when does Acorn become available for Windows to alpha test? You can receive an update, that kind of thing. So we can post the link in the description with you, Hidayat, for the Google form.
Thank you. That is great. You are going to provide the links, and I'm going to put in the description for sure. Yeah. So if nobody has any question, let's jump into quick demo that the people can see what's happening, what is Acorn, how it is working, then design and architect.
Okay, great. Let's see if I have, right, I do. Yeah. Please. Okay, you have my whole screen.
Yes.
Okay, great. Yeah, so because of the fact that Acorn is an Electron application, that means we're able to like actually install it natively and launch it from the application bar like this. Have a app icon, everything. That's your little welcome screen that splashes up before it launches the application. And you didn't see it this time because I've launched it before, but when you launch Acorn for the first time, as an example of like the use of Holochain, what it does the first time when you launch is it will wait on that screen and tell you what it's doing. For example, it's generating your private keys. On the very first launch, it generates your private keys and it tells you that that's what it's doing. And then on the second launch, you've already got your keys. So, so this is Acorn dashboard. It's a list of projects. And so each project is a chance to collaborate or work individually by yourself on what we call a tree, which is why this is called Acorn, because it uses the whole metaphor of trees in order to visualize work and jobs to be done, or even goals or aspirations. So, so for example, with Acorn, we go into Acorn. I want to go over to a specific one. It's over here. Here we go here. So this is an example of a tree within Acorn. This is to do with Acorn itself. This is us using Acorn to kind of plan out future development work of Acorn. And yeah, so you see kind of like basic little card structures, maybe inspired by like kind of like a Trello card or something along those lines. And each one can have a whole bunch of either data tagged onto it, or as well as relationships to other goals. And generally, these relationships mean that these things need to be done in order for this to become done. So for example, if we were to go through the process to complete all of this work, then I would probably be starting at the bottom, and I would be changing the status of these different goals, making them green, and as that work completed, I might also say, well, since those were all tasks involved in completing this one, I would also switch this one to green, since that's now done as well. And perhaps this one's done as well, and perhaps this one is done as well, and it bubbles up all the way to the top. If I've come everything at the bottom, potentially I might not have. I might need to add, say this takes a few.
Oh, I think Connor disconnected. Am I right? So let's pause the video. It seems there was an internet issue with Connor. Let's pause the video, waiting for Connor, and then continue. Please.
Okay, so we were just going through the tree and seeing about completing these things and how completing subtasks contributes to things up the tree becoming complete. But also, if we expand the tree, which is to say that there's still work that's required to make this task happen. We call it another subtask. I would want to switch this one back off from being red. Maybe I would make it in process, since some of it's done and some of it's not done. So these are elements of the tree. You can also kind of make connections between things. So you can adapt the and say a sub. I'm not going to connect those because that's not right. And we can also use just a bunch of different functions that we call the quick edit functions to do things like assign and unassign people. For example, if I could take myself off of this task. There's lots to show, but I won't necessarily go through everything. I want to just show you the expanded view card, which gives you kind of a larger way to access and edit the thing. For example, adding a description to the work, kind of standard things like that. Also adding a time frame like this. We can say this is when this work or this goal has to become done. And there's also a comment section. Now, one thing about this that I want to show you, just because I think it demonstrates kind of the layers of things, including the real-time aspect of collaboration that we've built into Acorn. We're currently looking at the goal map tree view. So I have another computer that's also looking at this same map, a collaborator. And if I was a collaborator and I added a comment, and that's real commenting on come in real time, and then Acorn
Connor, can you hear me?
Happen in okay.
Please.
Okay, so just to recap what happened there, and we can do one more demonstration of it. We have real-time collaboration in Acorn. So I have another person who's currently on the map, and they can make comments, and we can see them in real time. So let's see, do this again. We go about this. And so that is the real-time collaboration, and you have it for comments, and you also have it for goals, new goals on the map, everything like that is peer-to-peer kind of real-time collaboration and Acorn. And you invite people by going here and clicking the plus, and you take the project information secret and you send it to them, and just via some kind of chat that you have, or an email or whatever, something not in Acorn, and they go to Acorn and they hit join project, and they type in their 5-letter word or five word secret, and then they click join project, and they're able to join the project, and they start to sync. They start to sync with your project, and they become a collaborator on that project. I'm going to stop there so that we can move on and get into the technical stuff.
Yes, that was amazing. Actually, from my point of view, to demo that the real project, collaboration project, so peer-to-peer, and also you can go for a sync messaging, and you can create a project and others can join you. So I think the feeling, the things that we would like to others to see what's happening, I think it is quite good enough. And I'm sure, and there are a bunch of details, there are a bunch of functionalities that you could even demo, but I think for right now it's enough. and we are going to actually go to the next section to see what did you do, how did you implement this one, and how the things are working. But before that, I would like to ask others if you have any question or anything, please. Otherwise, I would like to continue to see how did I understand and how did I explore the project. Is there any question, guys? So, Malombo seems unmuted.
Yeah, so I was going to ask a question, but maybe you're going to come to it. I'm curious about the collaborative part, which could be separated from the application itself, and whether you have this in a kind of reusable component that somebody could take it and then plug a different application there.
This is the collaborative real-time part. A lot of, I would say it's not like cleanly separated within the code necessarily like already. I can see that there could be ways to, without too much labor, create separation between the things that are specific to Acorn and the things that are not as specific. This little patterns or data structures that we use in the real-time collaborative part. It's not currently separated that way, but I can imagine that it could be done without a great deal of difficulty. Although I do know that there's other projects, for example, you may have heard about SYN in the works that kind of are going to really focus on that aspect in itself, which is the real-time collaborative part. So I would place my bets on SYN as the best and the first opportunity to have a reusable library for that.
That is great. Good point, Malamo. Thank you.
Yeah, thanks.
Yeah, that would be great. So let's go to the next step that I tried to understand the project. I opened it, I read it. So I'm going to see that how much I'm right about understanding the design and architect and implementation. And then Connor is going to help us to see if we are correct. So let me share my screen. So first of all, it is the GitHub project. I'm going to share this URL in description. You can find it there. One important point that there is a branch for the Holochain-in-Action. So because for sure, after a while, after recording this session and video, there are going to be some changes, but Connor created a specific branch for us that it's going to be synced with this video. The later changes is not going to affect you. So it is a project. So as you can see, it is the way that you can run, and also there is a way that you can receive a newsletter about project status that to go for you can test it by yourself. But there is description here as a technical overview. I read it. Let me scroll here, and you can also pause the video later on and read in detail for the one version here. That's it. It's explained. I'm not going to read right now because it takes time, but I'm going to tell you that there are a few sections that Electron part, which is UI, that is amazing if you are thinking how to bring up application in peer-to-peer distributed based on the holochain using Electron. Acorn is a good example for you. Connor and Acorn project using embedded holochain runner. As you can see, I'm going to review this, how the UI is supposed to use and benefit from that. So, and also a conductor, how one example is coming up, and also the design and architect that it's explained here. After reading this one, I try to understand this. So I'm going to explain can you see my screen, guys?
Yeah.
So that's great. I'm going to, especially here, when it is talking about a cell, okay? I recognize I need to understand how Acorn architect and design, and then try to explore the project without understanding the architect and design and the mindset, it's going to be a little bit confusing. So it is the way, first of all, let's see how the holochain working and what is the general pattern in the holochain and conductor. And then let's see what is the design and architect of Acorn and how Acorn going to use holochain. And let's see how much we are right, or am I right? And I got the point. Generally, in the holochain, common way of implementing applications. So, you know, at the end, it is the conductor. You implement everything, zone, DNA, and then a conductor is supposed to install your application and actually do the main job. So it means if it is your PC or your machine or later on maybe mobile, so it is in a holochain ecosystem, not holo or holoport. We are just talking about the holochain. So it can be browser or it can be any consumer. So one conductor is supposed to be run. Application is going to be started in the common way of a holochain. Then we can have a different cell. So each cell, it means one DNA, one agent key, public key. What does it mean? Just imagine Instagram version on holochain. How Instagram working right now, and if you would like to have a different profile, you need to go to Instagram, create a different email addresses, and then register with the different email addresses. So just imagine different profile as a cell. If you install with the same DNA, you change your key, it means you have a different profile and different cell. If you would like to have another instance or cell of that application, you either can change the DNA or you can generate a new public key, private key, and install again that one. It means just bring up a new version. You're calling them cell. Connor, please, anytime you would like to interrupt me and add extra explanation, warm welcome.
Yeah,
so
one thing right about this, Hidayat.
Yes.
This is very good visualization. The only correction that I would make to it is that the agent key within a specific hApp has to always be the same for within that hApp. So for example, the green one, since it's in the same hApp as the blue and purple ones, needs to match the agent key of the other ones as well. So it needs to be agent key 1 as well. The agent always needs to match within the hApp. So the DNA can change within a hApp. The agent key can only change within a different hApp. You have hApp 2 and hApp 3 there. They could each have agent key 1 or agent key 2 and agent key 3, or they could share the same agent key as hApp 1. But other than that, it's a really good visualization.
Thank you for correction. That is fantastic. And also, what does it mean when we are talking about DNA 1 and DNA 2 and 3? We are going to reach it. It is the beauty. It is one of the beauty of design that we can have in a holochain ecosystem, and also Connor is going to use. It is the way that a normal common architect of a holochain application, suppose that you need, and they suggest you that to implement in that pattern. But Connor actually designed in a little bit different way. I'm gonna go and to see that am I right or wrong. But before that one, is there any question here, guys? Because it is a basic knowledge that we can focus on it, we can discuss it before going to the design and architect of Acorn. It is not Acorn design.
Yeah, perhaps just a brief question, Connor.
Yes.
So are you already interfacing with some kind of profiles and personas, Zome or Deep Key, or are you like working with your own layer around identity?
Jakub, can I pose this question? Let's jump it in the right moment, okay? I don't see Jakub. So I would like to pose this question. Just, we are going to reach it really soon. But is there any question about this one? How the things are working? What does it mean, hApps, cell, installing DNA? If there is any question here, please. Otherwise, I would like to continue and open up Jakub question. So let's continue. It is a normal way, but Acorn and Connor introduced this architecture. It is my understanding, and again, Connor is going to help me that, am I right or wrong, or how the things is working. In this architect, we have a conductor. So when we install the Acorn application, there is a one cell installed with a profile DNA. It is the question of Jakub. Profile DNA is going to be there, and we are going to look at the module, which profile Connor used. So it is a profile DNA, one DNA. Everybody who installs the application, I guess, are going to be inside this, and they are going to see each other, to meet each other. It's going to be kind of lobby. So, and then when they would like, just imagine this one and this one. It means I install application on my client. So one application is going to be installed with one cell, and it is me, and it is other friends that install this application, Acorn. Just imagine it is Jakub. So, and Jakub are going to install the same, and it is Jakub, for example. And then I would like to create a project with Jakub. I would create a one project which install a new application. It is not going to create a new cell. It's create a new application with one cell and clone a DNA named project DNA. Who is gonna be there? I can clone it with a new string, the 5 keyword that Connor explained. We will see in detail how it is working technically, how we can implement that one. The unique DNA is gonna come, and I would pass through the 5 key to Jakub, and Jakub would install exactly the same DNA, and then we can join each other. We can see each other. So we can join to that DNA in one cell, me and Jakub on our PC or on our machine. It is the way that, and in this one, another example, just imagine I would like to create another project with this color, with this green and other one. I create another 5 unique string. I clone the project DNA, and others also doing the same, put that 5 keyword, they clone exactly the same DNA, and then all of us can join the same DNA and work on the same project. Connor, am I right about your architect? Did I get it right? Is that true?
Yeah, you did really well. Yeah, that's very accurate to it. Totally the global kind of the profiles space, and to Jakub's question, it doesn't use any kind of other profiles. One, they didn't exist when we started Acorn. Maybe more recently they've become more mature, so we could actually maybe integrate them or reuse that code. It may be a little bit unnecessary what we've got right now. Other than that, I think we implement some real-time, some signaling between peers that's maybe not implemented in the profiles library that that has been shared, I think, in Holochain Open Dev. So we have just our own Zome for profiles. It's a pretty lightweight Zome. It's pretty small, so it's not terribly, there's not a lot of overhead to us maintaining it ourselves either. But in the future, it'd be lovely to integrate it with other things. This is just that Acorn has been around for a while and evolving for a while, and it was the best to kind of like put it in its own I don't know, to just have kind of, to not rely on anything external when we were building it in those early stages. However, nowadays we could maybe do a lot more to make it integrate or play well with those other implementations of the profiles piece. And And the only thing, so I want to say that you got it right, Hidayat. And the only caveat that I want to add, which is kind of funny to say, but it's that the reason why I architected it the way that I did is not because of some ultimately fantastic reason to implement it that way. It was actually due to a technical constraint that I faced with Holochain in terms of fetching back info from the conductor. And so just to say that in the future, potentially we could clone all of those, all of these things could be installed as cells within the same hApp because they all share the same agent key anyways. So in the future, we might change it so that it's a bunch of cells within a hApp, but ultimately it doesn't make too much of a difference to us one way or the other in this particular case. But the way that you've outlined it is accurate to how it currently is, but maybe just not to how it will always be.
I see.
Yeah.
And by the way, meanwhile, I gave you the permission to control my mouse. If you would like to explain zoom in, zoom out, warm welcome. You have the permission to do that.
Okay.
But Jakub, did you receive your answer? Do you have any more question about the profile? And
yeah, I did. Thank you.
You're welcome. So generally, it means right now, we are talking about current, right now, at the moment. As we talked, we already discussed, in the future, maybe the design is going to be chain and architect, but right now it is working in this way.
Yeah.
So it means we just have a two specific DNA design: profile DNA, project DNA.
Yeah.
Profile DNA is a kind of lobby. It's going to be installed at the beginning. People are going to join, see each other, to just contact each other, to create a project DNA, join in totally standalone, isolated area for their project.
Yeah.
That is great. So, and for the people who are watching that, when you install and you join 2-3, this area is going to be yours. It means it is a permission that you only can access to that project. And I have a question. What kind of, here it is obvious that people can just see by username or anything. So is there any special thing you would like about the general definition of profile that which is remained? What is the usage of profile and what kind of data or what kind of functionality we can find?
Yeah, I was thinking about your word lobby, and it would be, I think in some ways it's a good description of it. In the future, you could make it so that you could actually receive invitations to projects within the lobby. You can't right now. So it's not really a lobby in that sense. You have to use some kind of external chat system to send someone your 5-letter secret. So you can't, you have no way within Acorn of sending someone that invitation, right? You have to use whatever chat mechanisms you have outside of the app in order to invite them. And
I
so
see.
There's nothing like that within the profiles thing, although there could be if it were to be a more general lobby, as you're saying. And also, we are also examining that pattern to think about whether that is the ideal. It was simple because basically, my goal here is to make it so that the user doesn't have to update their profile many times, right? They should only have to update their profile once. That's the user story that I want, right? Is that I update my profile and all people who collaborate with me see my updated profile. And that's the purpose of the profiles DNA. It's so that I can only update my profile once and all my peers see that reflected regardless of which project we share. But my profile data is also potentially being leaked to people that I don't want it to be leaked to, since it's so global. And so there's a consideration there that we haven't walked that privacy line yet on this profiles DNA. So that's like a disclaimer about our design for this, is that we'd like to provide the same solution as we provide, but without compromising your any privacy, which I would say we currently do in a lightweight kind of way, that we'd like to just that before we would ever launch Acorn officially, we would probably solve that problem. We would solve that problem. Yeah.
Thank you. Got it. So it means profile right now is as it is. So the people can, everybody can see each other, but definitely we are going in the future to have more pattern, specific pattern, that how we can create a little bit more privacy there.
Yeah.
And we got it. We are going to review profile. So, and then about the project, it is another DNA. When I create a project and I would like to invite others, I can clone it, how we can clone it and how we can create a unique DNA. We are going to review it later in code, but I just want to know all the collaboration, all the details about the project, everything is going to be inside the DNA. That is correct?
Yes.
So, and collaboration also is going to be there.
Yeah.
That's great. So from design and architect, actually it was the way I got it. So thank you for correcting me. Right now, I really would like to jump into the code, but I would like to ask other if there is any question, please. No? Okay. So how about 5-minute break?
Sure.
So after a 5-minute break, I'm gonna again share my screen and let's explore the project that what we have. So can you see my screen, guys? So I'm going to open the project so to see what we have in the project and how the things are working. First of all, from a UI, generally as far as I got, and again, it is so far, it is my reference that to understand the layers and to have a little bit technical deep dive here. And I use this one, I read this one, and I'm going to see how the thing's working. In a UI, generally, it is the Electron technology. So obviously it is the famous one. We can explore, it means it is here. So we have a DNA here. We talked about the 2 DNA generally we have inside the DNA. Generally, I go to DNA, I open the tunnel at this one and see what use. We are going to review this one later on to see. So we have a zone. It is the profile that we already discussed, and it is the project. Yes, this 2-1 again to show for the fresh profile and project, which is here. So in the profile, we are going to take a look at both of them. So in the work directory, so in the profile, so for you guys to see how the things are working, cloning and generating, I think it is the property of a modifier. I think you override this one, Connor, for a new project, yes?
No, not quite. I modified the UID.
UID, yes.
So the modifier sits there as a thing that you can change in order to do what we call bumping your hash space, which you bump your hash space when you don't want to experience conflicts or overlaps between let's say development mode and production mode, for example. Like when you want, or if you wanted to have different almost like channels, for example, a development channel, a staging channel, and the production channel. Think about setting your modifier to be one of these 3 channels, and so it's just another layer of something that you can tweak in order to introduce variability, but consistent variability into your hash spaces. But then that's before you get into setting the UID. But one broader thing that I wanted to point out, Hidayat, about the skeleton is that there's two, you're in the part that relate to, I guess there's 4 top level folders, and they relate, they can be related to the kind of back end and the front end. And the conductor and the DNA relate to the back end. And Electron and web relate to the front end. So web is the pure HTML, CSS, JavaScript implementation. That's where the UI itself is written. For example, you use Webpack to bundle it, etc. Classic web stack stuff. Electron folder is simply what we call the thin wrapper, which knows how to load the UI and provides the browser window. So that's the skeleton. There, you'll find the Electron code in that folder is really, really minimal. It's just the total number of lines of code in this folder are really small, because it doesn't take much to implement the Electron wrapper around the UI.
That is amazing. So
code here is really small in Electron. All the majority of the UI code is in web. It's where the sophistication of the UI lives.
If I want to thank you that you came back to the skeleton, it is beautiful. So if I want to map this skeleton to this one, that how the things are working, it means here, let me zoom out. Here it means when here actually the Electron, the web is going to be this one. Electron is just creating a wrapper around this browser actually. And then with this project of the Conductor, you are going to have this Conductor running. So, and then the Electron just under the wrapper, and then you connect directly from your browser to the Conductor. And for each project, you create a new app. That it means the whole job is going to be inside the Conductor. Yes. Then the main topic of a cloning new project.
Just like point of clarification, like look at this application you're using right now, VS Code, for example. VS Code is itself an Electron application, right? And so it's a browser. It's technically a browser window without a URL bar. So just think of that. It's basically Chrome, but without a URL bar within which to navigate around. It relies on a different navigation system. And that's all that the Electron layer, well, it's responsible for 2 things. It's responsible for starting the Conductor when you launch the application. It's responsible for stopping the Conductor when you quit the application. And it's responsible for loading the UI, which itself, you know, the UI needs to connect to the Conductor. And so the UI, so Electron starts the Conductor, it waits for the Conductor to be running, and then it launches the UI so that the UI knows that the Conductor is ready by the time that it presents, by the time that it appears. That's why we have the splash screen first, and then the main window, because during the splash screen, it's launching the Conductor.
I got it. So I need to do a little bit change here to exactly demonstrate, but I think obviously it is clear right now. And so what is the Conductor does exactly in global? Because I saw here that you are using an embedded holochain runner, and I read it here that what is the Conductor holochain embedded runner. So if you can explain, because I just opened it. So what is the embedded holochain runner? How do you use it, and how it is different from the original Conductor of holochain? And we can also switch to your desktop, or you can control my desktop, up to you.
Right. you can just go back to the
you have a control, you have a mouse control.
All right. I can control, like I can.
Yes, you can. Yeah.
Oh yeah. Okay. I see. Okay. Right. So, oops. So, the main reason why I wanted to build an embedded Holochain runner, as we call it, is because the configuration options for the main Holochain conductor can almost be overwhelming, in the sense that there's lots of options. And what I was thinking about was, for most use cases, I only want to tweak a couple of those options. Basically, I thought of it as a simplified configuration pathway. The main Holochain conductor you have to configure with lots of different things, but the embedded Holochain runner, you only have to, oh, it's the scrolling's a little jumpy for me. Will you just scroll to the top and show kind of these main,
we can go to your desktop if you would like, if you have a project open.
No, just scroll down just a little bit. And we can sit right there. Yeah, so we're on this option here, this struct opt. So proxy URL, key store path, admin WebSocket port, app WebSocket port. Basically, this structure, this being like the main things that we wanted to configure for a Holochain conductor, and the rest of it would be kind of extraneous. And so we hide all of those configuration options that we don't want in the embedded Holochain runner. We set good defaults, and now we only provide this minimal set of configuration options for this particular conductor binary. So if we were to just run this from the command line, first of all, it would also have good defaults. We see the defaults are main app 8888 1234 key store. These are up in the and the default value for the Kitsune proxy. So just having all of those default values there means that when we call this binary, we don't have to think about too much about the values that we pass it to configure Holochain. So it lets us configure Holochain within Rust more so than outside of Rust, and there's kind of a convenience layer to that. The other major thing, look at those lines 5 and 6. This is a major part of the point of embedded Holochain runner. We actually use this macro in Rust called include bytes, and this is the kind of very unique part of embedded Holochain runner, is that this won't be too useful, this part here, but basically it takes our Holochain DNAs and actually just includes them in the binary that's going to compile from this crate itself. So go back to main.rs. So when we call include bytes on those two lines, it actually brings in the entire raw bytes of the Holochain DNA and keeps it in memory, keeps it in the size of the binary. So the binary includes, for this conductor folder here, it includes already the bytes for the profiles DNA and the project's DNA. And what that means is that it's very quick to load, because all of the data for the DNAs are already here in the binary and don't need to be loaded during runtime. They're built in at compile time. And so it's pretty fast, and it's also pretty simple. So you can see it pulls in the compiled DNAs if they're available and compiled. You can see that it references the DNA folder.
Yes,
Dot
the
slash
DNA
dot
folder,
slash
work direct. I didn't build it, but it's going to be here
Right.
if we build our package. Yes,
It's going to be there. Yeah, exactly.
Mhm.
It's going to be there once those DNAs are built.
build there.
compiled. The profiles.dna is going to be sitting there. Projects.dna is going to be sitting there.
So
And these references here on lines 5 and 6 of // DNA, they build in those DNA binaries at compile time. So that means that they're just super handy for when the UI wants to do the cloning and the everything like that.
That is great. It means actually, it means you create another wrapper actually, or I don't know to say wrapper, or it means this one. It means conductor. We are going to have a conductor with the loaded assembly or binary ready for cloning, and it is in memory. So we can easily create a new project and clone a DNA and install a new application. So that's going.
Yeah, exactly. Yes. It's kind of like preloading.
Preloading. That is great. Go. So can I go for a generic comment that this pattern can be useful if anybody in which situation it is a useful pattern? It means when project and how they would receive benefit by using this pattern. We recognize that by preloading some binary, and if they would like to clone DNA, it's going to be super fast. And is there any other reason?
Scroll down from there to where we see it pass in. So we construct right here, down a little bit where we define DNAs on line 65. And then we're going to call the async main function with an HC config. And HC config includes the DNAs as well as the configuration options for the conductor. So we know that profiles DNA and projects DNA from the top are the actual bytes of the holochain DNA, well, on line 66 and 67. We also give what's called a slot name. We can kind of gloss over that a little bit right now, but there's a slot name that says where's this profiles DNA and projects DNA gonna go? It's basically from where it's gonna be clonable, a name by which it's gonna be clonable, I think, is accurate to say. And then when we call async main, which is an export from the embedded holochain runner on line 75, we call async main. This is the main. This is the main. Us performing the core function of this binary. So this is the most important function call in this file. This is where we actually go into. This is what embedded holochain runner provides for us. It launches the conductor, and it also generates keys and installs the DNAs that you pass it.
I see. It is the place that actually you create, you install a new application with one cell inside.
Yeah, and note the name on line 70, install or pass through, which is important. The idea of install or pass through, this is the major thing that I think embedded holochain runner offers you, which is that this is the binary that you're going to get from this. You can call it once, and then you can call it again. Like you can start the process and stop the process, and then you can call it a second time. And on the second time, it's going to load the private keys and everything that were generated when you ran it the first time. And so it's basically, it generates the private keys on the first run. which is called the install step. And on the second run, it does what's called the pass-through, which is that it skips over all of the installation and the private key generation, etc., because it did all of that on the first run. And so this is really useful if you want to create something where on application shutdown, you want them to have the same identity and the same state when you start up again, which is most applications. And so that's the general use case for embedded Holochain runner.
That is amazing. And did you also intervene the place of saving data and a key? It means, or also you rely on a conductor for generating key or everything. It's exactly rely on the main source code of conductor, yes?
Yeah, I think I follow what you're saying. It all refers in the second run to the same things as during the first run. So if you just point it to a path, a folder on your computer, you say, here's my folder. This is where I want to generate my keys and install my DNA and everything. All my state, my application state should live in this one folder. And I want it to be the same. I want it to use the same configuration during my second time running the thing as from the first time. So it allows, let's jump out from here just so that you understand from where in Electron this is being called. So go to Electron.
Okay. I'm in Conductor. Let's go to Electron.
And go to Holochain. You can see that run Holochain, as I said in the introduction, Electron is responsible for starting Holochain when the application launches and stopping Holochain when the application quits. So what we wanted was a really simple way to start and to stop Holochain, which is why we built embedded Holochain runner, because we just wanted it to start up and shut down based on a set of simple configurations options and forget the rest. Not have to do a whole bunch of driving the conductor from within Electron, which is what we had in the last iteration. So I'll just point out line 109, which is where we say line 109, holochain handle equals child process dot spawn holochain binary path. So holochain binary path is the compiled conductor, which with the embedded holochain runner. That's what holochain binary path should point to. An options array is just a bunch of the options to pass to the holochain binary path. So basically, line 109 is solely responsible for starting the conductor. So
that is amazing.
So when you call run holochain within Electron, it starts the holochain conductor and does all whatever it's supposed to do. It generates keys, it installs the DNA. All of that's happening during the startup of this child process dot spawn. And then we're just saying we're listening to a feed of events in the being streamed basically through the command line that is indicating the state of the conductor. So for example, state signal dot is ready, line 116. We wait for the state signal is ready before we resolve this run holochain function overall.
That is amazing. That is amazing.
We're just kind of creating a very simple, we're saying kick off the conductor, wait for state signal is ready, and once state signal is ready, comes out of the conductor, we know that it's ready, and now we can launch the browser window because the holochain conductor is all ready to go. Is that making sense?
Totally.
Connor, just a quick question. So what is the way that you are actually calling the embedded runner from the Electron, is it a WebRTC or is it a direct call to the binary which is being run by the Electron, or how is the child process being called?
So the folder at the top level called Conductor is being compiled into a binary. And then all the Electron needs to know is what is the path of that binary. Embedded Holochain Runner is buried in the weeds of that Conductor folder and that binary. And so basically the Conductor binary, Embedded Holochain Runner is internal to that. We can sort of, once we know about what Embedded Holochain Runner is doing, we can sort of forget about it and we can say, now we just have this conductor. The conductor is great because it's this magical conductor that basically does everything we want it to do. And now we're in Electron and we just say, where's my conductor? Where's that binary for the conductor? And what options do I need to pass it in order to execute it with my preferred configuration?
But just to clarify, so so the Electron app is able to run the binary, or
yeah, it's able to run that whole conductor binary as a child process.
Okay, thanks.
And Embedded Holochain Runner knows how to run the conductor as a within the binary as a child process. It's kind of, that's all handled in the guts of the conductor.
Thanks.
Right.
I also see I see here, so there is I'm in the embedded holochain runner, and I see also a simple demo. In the simple demo, it seems using embedded holochain runner, it seems there is a totally simple DNA, and you already have a nice demo here. So, and DNA example is here. It is just an empty DNA example. Yeah. So it is just the empty DNA. That's it. Yeah. You created a DNA and then you build. Oh, that is great. It's really one working example to understand how this embedded holochain runner is running. That is amazing. Thank you. Thank you.
Yeah, so you kind of have a simple demo and you have Acorn, which is a sophisticated or a quite a complex example. Yeah.
So for sure, it's highly recommended to go and run a simple demo of the embedded holochain runner with empty and simple DNA to see how the things are working. And also it is a good documentation here. I love it. So, and then when we got the point, it is the complex version of the things that is working.
Yeah.
So,
great point, great find.
Yeah, that is great. That is great. So about the skeleton, we recognize the web. It's pretty much everything about the UI that we saw in your demo, about the web, about all the toolings part, drawing part, everything that we can see here, everything is here. And Electron is bringing up, and I didn't know, and right now I know that Electron is going to be the main process actually. So Electron is gonna come up. So, and then it's going to talk to the conductor, this embedded version, to open it, to run it actually. And then the conductor is going to load the assembly and the bytes, the profile and project. And for sure, for any project that any 2% that I already showed here, if I would like to, this 2.1 is going to create a new project. Conductor supposed to clone a new DNA based on the 5 unique words that we are going to discuss how the thing is working. And you install a new application here. Here in the conductor, we saw it, install application.
That actually takes place in the UI side code because it drives the conductor from the UI when you do that stuff. So that would be, we would find that in the web folder, but it's probably beyond what we can drill in.
Just the place, no detail. Place.
Yeah. So web source. routes. Routes is the top level. Routes is the top level navigation, and then dashboard, and then dashboard.js, and yeah, that one. And then so this one is the main dashboard, and it's responsible. It's got the React code, but it's also got a bunch of the project related logic down at the bottom. So you see join a project, etc. This is all React code. But at the very bottom of the file, you can find stuff related to join a project and to create a project. Here we go. So
here.
Yeah. So
yes,
there's some overlap right in this between. So you see this one's called install project app, but two different functions call this function, and that is join project and create project, because both of those actions result in installing a project. So scroll down a little bit and just see how both functions, one called join app and one called create, create project.
Create project, yes, I found
so
yes.
Create project calls install project app, but so does join project, which is just beneath it on line 311. You can see both of them call install project app as the very first thing, and that's because that's an overlapping behavior, is that it's going to either create one or join one. Either way, it's going to install that DNA. It's going to clone the project's DNA. It's going to do that kind of stuff. So let's go pop back up to the one that you were looking at, which was the this one. So this is the kind of key to the project's functionality. It requires admin level control over the conductor, which is entirely possible. But the line 263, we get the admin WebSocket, which is the thing which allows us to drive the admin functions of the conductor.
Okay.
So
I see for
yeah.
Go ahead, please.
We'll just jump back to the other one, the dashboard.
The dashboard JS, you mean?
Yeah. And just like that, we see that it's finding the project's DNA. It's registering a version of that DNA with the unique UID. On lines 275, lines 275 to 278. That's where it's actually registering a new DNA with a specific UID, and then it's installing a hApp which uses that DNA, which produces a cell, and then we just activate it and we capture the cell ID, which is an important thing for us to be able to reference throughout the code. So basically, this function very much performs that core logic that you're getting at in your architecture diagram. You can see on the very first line, it converts from a passphrase to a UID. Passphrase is a 5-word secret. 5-word secret.
Yes.
Dog, cat, and then it just joins it into a single string in a uniform way. And there we get our UID from our secret. That's how we make that jump. The project or the app ID is not too important, it's just coming up with an app ID. It's a bit important, but we can go back to it. And then it just needs to know the right path to clone the DNA, the project's DNA, which is what that function call is responsible for.
And I have a question. I don't want to go detail, but I'm a little bit curious. I would like to know that. It was a binary what coming from a memory. Why it is looking at the DNA project from a Word directory again here?
Yeah, that one is actually going to be wrong. That one on line 274, it doesn't actually really get used. I guess it's a bit of a legacy code there. The first part, first part on line 273 is active. However, I think that I misspoke when it came to the cloning as of this version of Holochain. It does actually, this one is still counting on there being a path and there being a project's DNA. And the cloning doesn't come from the one that's in memory. So good catch. It actually comes from a project's DNA file, which is sitting standalone, unembedded in the other one. So it needs a path to the DNA in order to clone it. In this particular case, don't get too hung up on it. Yeah.
Okay, got it. I think I need to sit on it personally. It's most probably is going for the next session to discover more the relation between this web actually. So it means what is the task and job is going to be split it up between a conductor and web, because the web is going to ask this conductor to please clone the DNA for me. I think we are going to leave it for the next because it is already a lot of context. So, but we got the whole point. What is the conductor? A wrapper to just make the things easier. DNA is going to be here. Next week, we are going to take a look at the design of a DNA, how profile is working. What does it mean cloning? How cloning is working for the next session. I think it's enough kind of. We got the point, the electron. Electron is the main process. I'm going to recap and review, Connor, any correction, please correct me. Electron is going to be main process. Electron is going to actually handle and take care of the conductor that, hey, conductor, start or shut down for me, and also bring up the web inside. And it is the web that's going to receive some information from a user, UI, 5 keyboard, try to generate DNA, actually try to generate this UII, this secret code. Where was it? Here. And then ask this conductor, would you please bring up this DNA with this five passphrase and clone a new DNA. And then install the application, which is here, install app. And then dang, the whole architect and design is going to be working.
Yeah.
And that is amazing job. That is amazing job.
It's well done to navigate through it, and yeah, it's really exciting to be sharing about it. It is it's a difficult thing to try to come up with or to understand, how can we pull this off? How can we make an application that bundles Holochain and where the user doesn't need to know about, there's no technical knowledge required when you launch Acorn, right? And that was our goal with it, is you just click on a launcher on your a launcher icon on your application bar, just like you do with anything else, and it's all taken care of for you, or it's easy. And so everything that you see is a result of the attempt to boil it down to an extremely simplified end user experience. And that's why the decisions that we made. And that means that we take on a bunch of complexity, as developers, but we take it on behalf of the end users in order to simplify that life. And this makes for, ultimately, I think what we've been told is a very good, very great kind of end user experience. And that's what we wanted to prove, can that be done with Holochain? What kind of end user experience can we deliver on with Holochain? And that's our sort of mission in a way with Acorn.
That is spectacular. I really enjoyed even to understand the architect and how you put the piece of puzzle here. So because anybody knows we are in the world of distributed peer-to-peer. So bring up application, talking to Conductor, so communication, so generate the key and cloning the DNA, all this stuff in a one application as a demo. Personally, I really enjoy. I know it is a lot of content for the session, and as we already talked with Connor, that we cannot cover everything in one part. So it seems with a lot of pleasure we are going to have for the next round of Holochain-in-Action, again, deep dive, technical deep dive, more in detail right now with a little bit more. We already covered the global overview on Architect. I would like to ask other if there is no question. Is there any question? Just last word from Connor, and then we can wrap it up today meeting. So there is no question. Connor, please just finish the session.
Sure. Well, I noticed myself kind of jumping in a lot and kind of like eager to share with you. I hope that that worked well or was reasonable for the session. I know it can be, there is a lot of different code, so figuring out what exactly are the good entry points and what exactly, where can we start to get oriented in this big code base. I haven't tried to do that with anyone exactly who also has your level of technical knowledge before Dive. So it's like, it's a powerful exercise, I guess, to say for me too, to figure out how do I communicate about this code base, which has grown pretty big and pretty sophisticated, and how do I even understand it well enough and communicate about it well enough to help provide people orientation. And your questions and your navigating through it are extremely helpful to that process. So thank you for inviting me.
I love to see you here. Thank you for coming. I learned a lot today. And yes, let's say that looking forward for the next part so that we go in more detail actually, and for sure on your computer, and we are gonna, personally, I'm gonna have a lot of questions, more and more in detail. Yeah. Again, thank you, and see you also the next time.
Awesome.
So, bye-bye. See you next week, guys.